So if you head way, way up into some of the most uh, punishing elevations of the American West,
Hmm.
think Nevada, Utah, California, you might just stumble upon an ancient beauty.
Mm.
And we're talking about a tree here, but it's often so gnarled and twisted.
Yeah.
The wood looks less like living timber and, I don't know, more like a sculpture.
Carved by centuries of just relentless wind and cold.
Exactly. These are the bristlecone pines.
And they're famous, really, all over the world for holding this remarkable title, the oldest individual plant life on Earth.
Right. So today we're doing a deep dive into the source material that details their life cycle, their survival strategies, and some really surprising discoveries about them.
Our mission is pretty straightforward.
We want to pull out the most critical nuggets for you about this species, and we're going to focus on the star of the show, Pinus longeva.
The Great Basin bristlecone pine.
That's the one.
And it's important to clarify that, right up front, the term bristlecone pine actually covers 3 different species. They're all in the same botanical family, but it is indeed longeva that takes the ultimate crown for age.
Okay, so let's unpack this then. We're looking at a plant that can live for 5,000 years.
Incredible, isn't it?
It is. We need to figure out what biological tricks allow it to basically defy time, and maybe more importantly, what the history that's etched into its wood can tell us about our environment's future. That's the knowledge we want to synthesize for you. So, when we talk about champion longevity, my mind immediately goes to these giant redwoods or sequoias in these lush green forests.
Right.
But Pinus longeva, it's not a creature of convenience. It seems to actively seek out the most aggressively difficult home it can find. Why would it choose that kind of punishment?
Well, it's a classic case of adversity breeding resilience. These trees, they thrive at really high elevations. We're talking above 1,700 meters, sometimes all the way up to 3,400 meters.
Oh.
And the environment is just defined by rocky, poor soil, extreme cold, and just constant wind. But that harshness, that's the secret to their success.
How does suffering help?
Well, the cold and the nutrient-poor soil, they force this intensely slow growth.
Okay.
I mean, think about a single growth ring that might be the width of a human hair. Because they grow so slowly, the wood they produce is incredibly dense.
So that density is key.
It's everything. It makes the wood highly resistant to insects, to fungus, to disease, all the things that are usually the primary causes of death for younger, softer, faster-growing trees.
So their lifespan is basically a side effect of them being unable to thrive in easy conditions.
Precisely. And they also produce these incredible amounts of resin, which is a natural preservative. It essentially mummifies their own wood even after the cells have stopped functioning.
That's amazing.
They also practice something like self-pruning. Often after centuries, you'll see a tree where only a small live strip of bark is connecting the root system to just a few living branches.
And the rest of the wood is dead.
The rest might be dead, but because it's so dense and just saturated with resin, it doesn't decay. It protects that thin, living strip of tissue like a shield.
That is just fascinating. It's essentially a 1,000-year-long adaptation to just resource scarcity and physical damage.
Mm.
And that tough, gnarled appearance you mentioned, that sculptural quality, that is literally the visible result of this slow-motion survival strategy.
Well, that gnarled look is what we see, yeah. But the name bristlecone actually comes from a detail you might miss if you weren't looking closely. The young cones are this deep purple color.
Okay.
But as they mature and open up, each little scale on the cone sports a tiny, sharp, characteristic bristle.
A powerful ancient survivor named for a tiny little spike.
It's a beautifully understated name.
It is. And that really tough upbringing is what makes them the longest living non-clonal plants in the world.
Mm-hmm.
But before we get to the real heavy hitters, we should probably acknowledge their relatives.
Right, who are no slouches themselves, even if the Great Basin bristlecone makes them look ancient.
Yeah.
The foxtail pine, Pinus balfouriana, has an oldest known individual that lived for over 2,100 years.
And then there's the Rocky Mountain bristlecone pine, Pinus aristata. That one pushes it to almost 2,500 years old.
Just to give you a historical marker on that Rocky Mountain tree sprang from its seed right around the time that early Greek philosophers were defining justice, and Confucius was laying the groundwork for Chinese thought.
That's just an unbelievable continuity of life.
It really is.
But if we look past those 2,000-year records and we focus on the Great Basin species, I mean, this is where it gets really compelling. We start dealing with what are called the mega-mature individuals.
Yeah. There's a whole group of them still standing in Nevada's Wheeler Peak cluster that are dated at roughly 3,000 years old. But that same location was home to the most famous and perhaps the most controversial bristlecone ever known, Prometheus. Right,
Prometheus,
yeah.
right? That was the one that was dated to be roughly 5,000 years old when it was chopped down in 1964.
Yeah.
I mean, an astonishing age. That tree was established when humans were still building the earliest cities in Mesopotamia. So why? Why was this ancient sentinel cut down?
It was a very controversial decision. It was driven by the science of dendrochronology.
Tree ring dating.
Exactly, the study of tree rings. The researcher, a man named Donald Curry, he needed to establish what's called a master chronology, a long, continuous sequence of ring patterns.
To date other things.
Right, to accurately date ancient ruins and archaeological sites in that region.
So the sacrifice was made for the sake of other historical knowledge.
It was. They needed that massive data set to create a reliable historical baseline that stretched back thousands of years. It was a trade-off, losing one spectacular individual to gain crucial data that helped date massive swaths of human history.
Still, it's...
Oh, absolutely. The decision caused, and it still causes, enormous grief in the scientific community, but the data that tree provided remains invaluable today.
So after Prometheus was lost, the undisputed title of the oldest living individual went to Methuselah.
Methuselah, yes. It grows in the Inyo National Forest in California and is currently dated at 4,700 years old.
But the record books were quietly rewritten.
Right. They were, in 2012. A new individual was discovered that is now estimated to be over 5,000 years old.
And its location is basically a state secret, isn't it?
It absolutely is. Its location is only known to this tiny group of scientists and park officials. There's no big signpost, no tourist trail, no catchy nickname.
Because the scientific community learned a very hard lesson from Prometheus.
They did. Keeping the location secret is the single most effective way to protect it from being disturbed and making sure this latest champion can continue its long watch in peace.
That secrecy really underscores the profound value we place on these individual ancient lives. But as we discussed earlier, talking about the oldest plant in the world, it's not as simple as just counting tree rings.
No.
The term oldest gets a little thorny.
It does. So we've established the bristlecone is the longest living non-clonal plant, meaning it came from a single seed, it's one genetically distinct organism.
Okay.
But nature has another strategy for longevity, and that is clonal reproduction.
Clonal plants. Those are the ones that reproduce asexually, right? They essentially just make copies of themselves.
Exactly. The genetic offspring is identical to the parent stock, and it often remains physically or chemically linked underground. So the individual stems or bushes that we see above ground, they might die and be replaced over and over.
But the core genetic organism, that ancient root system, can live on almost indefinitely.
That's the idea.
And these clonal giants, they really connect us to a much bigger picture of geological time. I mean, the lifespan of a single bristlecone is amazing, but compare it to, say, Palmer's oak in the Drupa Mountains in California.
Oh, yeah. This is a colony of bush-like clones that all originated from a single acorn and estimated 13,000 years ago.
13,000.
Yeah. And while the individual shrubs are short, maybe a meter tall, the entire colony spans over 2.5 kilometers. That single genetic organism survived the end of the last ice age.
13 millennia.
Yeah.
That is just mind-bending. And there's one even older that just redefines our concept of time. King's Holly down in Tasmania.
King's Holly is thought to be the oldest discovered plant in the world. It's a clone of an original that lived an astonishing 43,000 years ago.
43,000.
To place that in context for you, that lineage was established long before the last woolly mammoths walked the earth and long, long before Neanderthals went extinct.
Wow. Okay, so if we connect this to the bigger picture, the distinction is really clear. For just sheer individual tenacity, resisting the elements for 5,000 years as one single entity, the bristlecone pine is unbeatable.
Unbeatable.
But for long-term genetic stock that just continually regenerates the clonal plants, they carry a lineage that truly spans deep time.
It just allows us to hold two different truths at the same time about what it really means to be ancient.
So let's pivot a little. Let's go from looking at the bristlecone pine as just a record holder to viewing it as a scientist would.
Okay.
Its age gives it an importance far beyond a simple record. This ancient organism is a unique and, irreplaceable barometer of the global environment.
And what's so fascinating here is a massive long-term study that used the tree rings, the very data that Prometheus died to provide,
Right.
and it revealed a distinct and, frankly, alarming recent change in the tree's behavior. They are effectively carrying 5,000 years of environmental data right in their core samples.
And what that data revealed was a significant and pretty much unprecedented shift in the last half century.
Researchers found that the growth of these bristlecone pines accelerated dramatically over the last 50 years.
Dramatically.
And this growth spurt was more significant than any other period in the tree's entire recorded history, which goes back 3 to 700 years.
So you have an organism that specialized in intense resource conservation and super slow growth for nearly 4 millennia. And it suddenly hits the gas. Why? What environmental variable changed so profoundly after centuries of stability?
The researchers correlated this unprecedented growth spurt directly to rising temperatures.
Ah.
The bristlecone pine is highly sensitive to cold, and its growth is severely limited by these short, harsh growing seasons at high altitudes.
So if the temperature rises,
Yeah.
it unlocks potential. How does that actually work?
Essentially, the growing season gets longer. That high-altitude environment used to keep the area frozen or near frozen for large parts of the year.
Right.
Warmer temperatures mean the snow melts earlier, the ground thaws deeper, and that increases the period when the tree can photosynthesize and access soil water that was previously just unavailable.
So it's like the harsh environment was putting a speed limit on its growth, and modern climate change is taking the limiter off.
That is a great analogy. And this provides such a critical long-term data set. I mean, we've only been measuring global temperatures with instruments for a few hundred years.
Yeah, a tiny blip in time.
The bristlecone pine gives us a 3,700-year perspective, and it proves that the growth acceleration we're seeing now is not just normal variability. It's a complete outlier compared to nearly 4 millennia of stable, slow growth.
So what does this all mean for you? The bristlecone pine isn't just a fascinating relic of the past. Its very growth patterns serve as a living, undeniable data point on modern climate change, written into the annual rings of the wisest tree on the planet.
It's an ancient, silent witness telling us exactly how fast our world is warming.
Which brings us to our final synthesis.
We've established that the Great Basin bristlecone is the undisputed champion of individual longevity, reaching 5,000 years.
Right, and that requires a really clear distinction from ancient clonal colonies, like the 43,000-year-old King's Holly.
And most critically, we now know that this species has transformed from a static object of history into an active data monitor. It's revealing critical and unprecedented insights into modern climate change through an acceleration of growth.
That's linked directly to rising global temperatures.
And this raises an important question for you to mull over. If the secret to the bristlecone pine's survival has always been its ability to endure harsh, stable conditions, to rely on slow growth and resource conservation, what happens to its future when those difficult conditions rapidly accelerate or fundamentally change due to global shifts? If its entire defense mechanism is slow stability, how well can it cope with rapid, high-speed change? What lessons can these ancient, silent witnesses teach us about the long-term tension between adaptation and stability?